Yeah, good evening, students. My voice is audible, right? Just give me a confirmation. Is my voice is audible to you all? Just you can comment in that. Yeah, okay, I got one thumbs up, right? And yes, I got one. Yes, right. Okay, okay, right. So I'll just wait for another 2 minutes. Okay, so if any others want to join in the Zoom meeting, let them join. Okay, so just 2 minutes. After that, we'll start. Anyways, I have displayed you the first question. Okay, the first question has been already displayed. You can try solving it, and once after 2 to 3 minutes, I will start the session. Okay, so we can start the session. So those who are new in the what is that? Those who are new in our what is that? In the Zoom portal, keep your voice in a mute itself. Okay, so for whenever you have a doubt, okay, the principle is very simple. Whenever you have a doubt, you just raise your hand. There will be an option to raise the hand. And once after raising the hand, you can unmute. That is, whenever I call your name, you can unmute it and you can answer. That is, you can ask your query. Okay. Until that, please keep your what is that? Keep your mic in mute, because due to your background noises, it might disturb other students. So I don't want that to happen. Whenever you have any doubt or whenever I ask any question, that time you can unmute and you can answer. Okay. So either you unmute and answer, or there is an option to comment. You comment it. Okay. Anything is fine for me. Okay. So just anything is fine for me, just in order to make sure that the session is not disturbed much. I don't want everyone to what is that? Everyone to open their like everyone to keep their voice in a normal mode. Okay. As of now, keep it in mute. Okay. Right. So just one more final confirmation. My voice and my screen both are properly visible, right? Just give me one confirmation. My voice and my screen. Right. Okay, Lord. Fine. Fine, then we can start. Consider a 3. Okay, I got 2 answers from Kishore and Hilal. Option B, yes, option B is correct. Okay, no problem. Option B is correct. We can start. I will solve anyways. I will solve the question for other students. So consider a 3 cross 3 matrix whose I comma jth element Aij. Aij as being given as I minus j whole power 3. Then the matrix A will be. So they are asking whether the matrix A will be symmetric, skew symmetric, unitary, or null. See, one thing I want to add for the other students who are attending the session for the first time. This session will be a problem solving session. So I'll be concentrating only on the problems rather than on the concept. So I will be giving you an idea about the concept, but not the complete idea about the concept. Okay. So I will be concentrating majorly on the problems. Okay. All right. See, let us first focus on what is mean by like I need to find out what type of matrices is this. Okay. See, if I take I is equal to j, if I make I and j both are same, what will happen to my matrix AII? My AII, that is both are same. Okay. I and j will be same. So it will become I minus I whole power 3. That's going to be 0. So the condition is something like AII will be 0 for all I is equal to j. Okay. So I'm just forming that elementary condition. Okay. Elementary condition from the given data. Okay, so ai will be, or else simply aij will be equal to 0 when I and j are same. So what happens if I and j are not same? Okay, if I and j are not same, what is going to happen? Let us check. If I and j are not same, we know aij, which has been already given to us in the question, which is I minus j whole power 3. And what will happen to my aji? Okay, which means I'm just replacing wherever I is there, I'm replacing it with j, and wherever j is there, I'm replacing it with I. Okay, so if I do it, my I will become j and my j will become I. You will understand why I'm doing this. Just wait for a moment. Okay, just wait for a moment. I will take minus sign commonly from this, and minus 1. Okay, when it comes out of the cube root, it will be minus. So minus of I minus j whole cube. We already know this I minus j whole cube is nothing but aij, so which is minus of aij. So I got aji is equal to minus of aij, or in a reverse way, aij is equal to minus of aji. And so what is our other condition? The other condition is when I is not equal to j, my aij was minus aij. And this corresponds to, I have already given you in the course, this corresponds to skew symmetric matrix, right? So in case of skew symmetric matrix, our diagonal element will be 0, and all the other element, that is, if I interchange, I'm sorry, I'm very sorry, this is aji. Okay, aij will be equal to minus of aji. That is, skew symmetric matrix is a is equal to minus of a transpose. So when I change the I and j, my answer will be in terms of negative. Okay, if it is a symmetric matrix, it is something like aij will be equal to aji. That's it. Okay, aij will be equal to aji. That's it. Okay, there is no condition for the diagonal element to be 0. But for a skew symmetric matrix, diagonal element should be 0. That's what actually happening. When I make I and j are same, my diagonal element is becoming 0. The other element will be like minus, that is, a will be equal to minus of a transpose, or else in this way. Okay, 0, 0, 0. This element and this element will be equal in magnitude, but opposite in direction. If one is positive, another one will be negative. And similarly, this element and this element will be equal in magnitude, but opposite in direction. Similarly, this and yeah, this is the third. Okay, first row, third element. Okay, first row and third element. And this is third row, second element, and second row, third element. Both of them will be equal, but with a negative sign. Okay, so that's what we got. So this is the elementary condition corresponding to skew symmetric matrix, and the given matrix is falling under skew symmetric matrix. And obviously, it is not a null matrix. It is not an unitary matrix also. So it is directly a skew symmetric matrix. Okay. See, again, I'm saying I'm not concentrating much on the concepts because all the concepts has been already discussed. It's a problem solving session, which is majorly used for improving the rank. Okay, something like a rank improvement session. Okay, so I'm moving to next question. I hope there is no doubt. I'm moving to next question. If there is any doubt, obviously, if there is any doubt, you just raise your hand. Okay, just raise your hand. And if there is any doubt, I will be clarifying it. Okay, so if you have a doubt, you raise your hand. I will be clarifying it. Okay, shall we move to next question? I got two answers, and try to answer it. It will be better if the session is more interactive. Okay, it will be better if the session is more interactive, which means if you try to answer it, it will be better. Okay, rather than just what I could say, listening to the solution. Okay, listening to the solution will not help you that much. I will be giving you the approach that is going to help you. But if you try it, and then whenever you get a doubt, and if you clarify that doubt, it's going to be more useful for you. Okay. So moving to next question. It's a good question. Try this. Now, first of all, read it. I will give you 1 minute time. Okay, just 1 minute time. And if you get any answer, if there is any answer from your side, it's an MCQ question only. Okay, if you get any answer from your side, give the answer. So any answers? Okay. Right. So I guess 1 minute is over, right? 60 seconds. I don't want to waste more time. Okay. That's why I was just giving you 1 minute. And this question doesn't need much to solve. It's like a direct conceptual question only. Yeah, I got one answer. Statement 2 correct. Okay, what about statement 1? Okay, so I got one answer, that is statement 2 is correct. That means option B, right? Okay, let me read the question. E power A denotes exponential of a square matrix. So if A is a square matrix, they are saying that E power A is the exponential of some square matrix. Okay. Suppose lambda is the eigenvalue and V is the corresponding eigenvector of matrix A. So for matrix A, they have given as eigenvalue, which is lambda, and eigenvector, which is V. Okay, so the data for eigenvalue and eigenvector of matrix A is given. And the statement related to a new matrix, that is exponential of A, is given. They said that E power lambda is the eigenvalue of E power A, and V is the eigenvector of E power A. Okay. See, we have to bring one small connection from our calculus. Okay. See, what is this E power A? From calculus, that is from Taylor series, I can write general only, like 1 plus x plus x square by 2 factorial. We know all these things. Okay. 3 factorial plus etc. from Taylor series. Okay, this is directly from Taylor series. So E power A can be written as 1 plus. So 1 in the sense, in this case, it is I, okay, because it's a matrix, right? It's a matrix. So it's a I, identity matrix, plus A, which is a normal, the square matrix, A square by 2 factorial, plus A cube by 3 factorial, plus etc. So E power A in the sense, this is our matrix. Okay, this is our matrix. And from Cayley-Hamilton theorem, okay, from Cayley-Hamilton theorem, every square matrix satisfies its own eigenvalue, right? So what I can do, that is every characteristic equation will satisfy its own, its own, every characteristic equation will satisfy its own matrix. I'm sorry, I said the theorem wrongly. So it satisfies its own matrix itself. So this is the, this is my E power A. That is okay. That is from Cayley-Hamilton theorem. Once again, I will just modify it. See, that is from Cayley-Hamilton theorem. But let me recollect one more thing. I have did one small mistake. This is E power A, right? This is E power A. And we know eigenvalue of A is lambda. Go to the properties of eigenvalue. So eigenvalues of an identity matrix will be 1. Eigenvalue of any matrix A power n will be equal to eigenvalue of a matrix A whole power n. So there is no requirement for Cayley-Hamilton theorem here. I said it wrongly. So wherever you have eigenvalue of A power n, simply find out eigenvalue of A, then rise to the power of n. Okay, that's what we need to do. So what I can do here, eigenvalue of E power A can be written as eigenvalue of I, okay, eigenvalue of I, plus eigenvalue of A, plus eigenvalue of A square by 2 factorial, plus etc. Eigenvalue of A cube by 3 factorial, etc. Eigenvalue of I is 1, we already know. Eigenvalue of A, we already know, which is lambda given. And eigenvalue of A square by 2 factorial, I will write to 1 by 2 factorial separately. Eigenvalue of A square is nothing but lambda square. That's a property, right? Eigenvalue of A power n is eigenvalue of A whole power n. Plus similarly, here I can write 1 by 3 factorial into lambda to the power of 3 plus etc. So that is my eigenvalue of E power A. Now say, what is this? This is eigenvalue of E power A, and what is this? 1 plus lambda square by 2 factorial plus lambda cube by 3 factorial plus lambda power 4 by 4 factorial. What is that?
To the power lambda.
Yes, E power lambda, exactly, Hilal, E power lambda. So I got my eigenvalue of E power A as E power lambda. So statement 1 is a correct statement. Okay, so statement 1 is a correct statement. A small link, okay, a small link between calculus, that is Taylor series, and the matrices will give us the answer. Okay, right. So we got one statement, that is we verified one statement. We'll look into the second statement. Okay, so they are saying that V is the eigenvector, which means we know that eigenvector of a matrix A is V. Okay, so I will give you one property here. Okay, so they given eigenvector of a matrix A as being given as V. Okay, right. We know e power A is a new matrix, which is nothing but a polynomial. Am I right? Because that is what we did in Taylor series. We converted e power A into a form of a polynomial, right? Polynomial, or I could say that polynomial matrix to be more precise, because it's a matrix. Okay, so e power A is a matrix which is in the form of polynomial. Okay, so it's a polynomial matrix. And now what this theorem says, a matrix A and its corresponding polynomial matrix. Okay, a matrix A and its corresponding polynomial matrix will have same eigenvector. Okay, so you take any matrix A, okay, and they given that the eigenvector of matrix A is V, and you take any polynomial of that matrix. For example, A square plus 2A, okay, 2, A power 4 plus 3 power A square plus whatever, okay, any polynomial, 4, 3, A power Q plus 3A. You take any polynomial, all those polynomial will have same eigenvectors. So that is a new property which I'm introducing here. Okay, so what does that property says? A and its corresponding polynomial matrix. So here e power A is a polynomial matrix corresponding to A. Okay, so A and its corresponding polynomial matrix will have same eigenvector. So, and the statement 2 is also correct, because we already know V is the eigenvector of e power A. So V is the eigenvector of A. So V is going to be eigenvector of e power A also. So statement 2 is also correct. Okay, so the correct answer for this is option C. Right? Is there any doubts in this, how both the statements are correct? I have given you the explanation. If there is no doubt, we can proceed to next. Say I'm not, anyways, for the students who are attending the session, that is those who are attending the free session, this video will be there in YouTube. Okay, so if you want to take any notes, you can take, that is, you can refer the video on the YouTube and you can take the notes. And if suppose for the registered students, obviously this video will be there in our portal, so you can take the notes later. Okay, so now it will be better if you try to solve the problem instead of taking notes. Okay, right? Any queries? Okay, right, no problem. Let us move to next question. Yeah, go through this and try to answer it. So they are asking us to find out C plus D. Okay, C is the coefficient of A and D is the coefficient of I. They're given 6A inverse equal to A square plus CA plus DI. Any answers? See, all are basic matrices only. Okay, all are basic matrices. And I hope most of you would have already studied, they have watched our video. Okay, listen, let me solve. Or I will give you another 30 seconds. Okay, another 30 seconds. Right. So we'll solve the problem. So 6A inverse equal to A square plus 6A plus DI, and they given us the matrix. And C and D are some scalars, and I is an antimatrix. They're asking us to find out C plus D. Okay. See, now we will use the Cayley-Hamilton theorem. Okay, if I use Cayley-Hamilton theorem, I can write 6 lambda to the power of -1. Oh, I got one answer, 5. Yeah, 5 is correct. All 5 is correct. Good, 5 is correct. So A can be replaced with lambda square plus C into lambda plus D into I is anyways 1. Okay, so I have just used my Cayley-Hamilton theorem and I got an equation corresponding to lambda. Okay, so now the problem is nothing because we have A. See, you could think, sir, like I can directly substitute this A. I will directly substitute this A in this equation. I'll find out A inverse, I'll find out A square, I'll find out A and all those things and substitute it here. Then I can find out C plus D, right? See, that is going to be that's going to take hell of a time. It's not that easy because you need to find out A inverse first. Then you need to find out A square. Okay, and finding out A inverse and A square itself, it's going to take you lots of time. Then you put it here and then find out C plus D by multiplying and adding all those things. Okay, that is going to take more time, but that is also a fine way, but it will take more time. Instead, what I can do, if I able to find out one lambda, okay, if I able to find out one lambda, then the problem could become very simpler. Okay, how can I do that? Simply A minus lambda I into x equal to 0 from the characteristic equation. Okay, so A minus lambda I don't know the lambda, so I want lambda, right? I'm sorry, this is for eigenvector. Determinant of A minus lambda, determinant of A minus lambda equal to 0. So what is my determinant of A minus lambda I? A minus lambda, so let me directly write it. Okay, so 1 minus lambda 0 0 0 4 minus lambda -2 0 1 and 1 minus lambda. Okay, so this is my matrices. Now find out determinant for this. Okay, I need to find out determinant for this. So that's going to be 1 minus lambda into 4 minus lambda into 1 minus lambda minus of -2 into 1 will become -2. Okay, so this is one term. And these two are anyway 0. Okay, so I will be getting 0 plus 0, which is equal to 0. So we don't have to do it again. Now solve this, you will get lambda. Okay, so I'm not going to do it. Just it is your task. Okay, just multiply all the terms inside one by one and then solve it. You will get lambda. Okay, so Hilal, what is the answer for lambda you got? You did it in this method or any other method?
No, sir. Actually, in this method, the characteristic equation I find, then I find to compare that the given equation 6A inverse equal to A square, then the answer is come. Not given to the lambda equal to.
You compared it with what?
In that equation, characteristic equation, I get a equation equal to lambda.
Yes, you will be getting an equation
and the given equation, that is the 6A inverse equal to A square plus CA plus DI. If I compare that two equation, I get the answer.
Okay, by comparing these two equations.
Yeah. Actually, if you are multiply that all the thing like 1 minus lambda, 4 minus lambda, 1 minus lambda plus 2, that you can given that type of same equation 6A inverse equal to A square plus CA plus DI.
Okay. Okay. So right. So we'll be getting it as lambda square, the same type of equation. Mhm. Okay, but we can determine lambda here, right? Okay. We can compare it. Right. Okay, right. That's fine. I understood. Hilal. Okay, so I can directly multiply it. So okay, let me do that. That might reduce the step further. Okay, instead of finding out lambda, we can directly compare it. That's fine. So one, that's going to be 4. That's going to be minus lambda. That's going to be minus 4 lambda. That is plus lambda square into 1 minus lambda plus 2, which is equal to 0. And again, further, I can multiply this. This anyways will be minus 5 lambda. So further, I will multiply it. So 4 minus 4 lambda. And this is minus 5 lambda plus 5 lambda square. And this will be multiplied. So plus lambda square minus lambda cube, which is equal to 0. So now if I solve this, something like lambda cube, and this is going to be minus 6 lambda square plus 9 lambda minus 4 equal to 0. Just I'm bringing all the terms to one side. Okay, all the terms to one side. So this is what I got. And from this, yes, as he said, we can multiply it. So here, or else I will bring this, and then I will find out. I will multiply lambda on both the sides. So it will become 6. This will become lambda cube plus 6. C lambda square plus d into lambda. Okay, right. And then just do the rearrangement. Lambda cube plus 6 c lambda square plus d lambda minus 6 equal to 0. I have 4 here, so I will just do the little bit of calculation. Oh, I got 4 here actually.
No, sir. That is 6. Actually, plus 2. You are not adding that plus 2.
Okay, I'm sorry. Yeah, I have not added this plus 2. Right. So 4 and 2 will get added, so it will become 6. Right. So this will be minus 6. Then fine. Just compare these two equations. So this is the equation which has been given to us from the Cayley-Hamilton theorem. And this is the equation which we got by solving the characteristic equation. So now if I compare it, I got C is equal to minus 6 and D is equal to 9. Okay, so okay, I have done some other mistake here. C is equal to minus 6 and D is equal to 9.
But D equal to 11 actually.
Yeah, one second. So this 4, and this is going to be minus lambda. This is going to be minus 4 lambda. This is going to be plus lambda square. Okay, so minus 5 lambda. And here it is 4. This is minus 5 lambda, right? So minus 4 lambda. This is minus 5 lambda plus 5 lambda square. So this is plus lambda square. So just check where I have done some calculation mistake here in between. I have done some calculation mistake. Can anyone verify this? The calculation mistake which I did in between. Or there's no problem. I will just do it again. It's going to be 4. 1 into 4, it is 4 minus lambda into minus lambda into 4. That's going to be 4 lambda, and minus lambda. This will become plus lambda square. So that is 4 minus 5 lambda plus lambda square. Okay, right. And the balance thing, it is 1 minus lambda I have. Okay, so this will become 4 minus 4 lambda. This is minus 5 lambda plus 5 lambda square. Okay, and plus lambda square minus lambda cube. That's what I'm getting again. 5 lambda square, 5 lambda 4.
Hello, sir.
Yes.
Actually, that determinant that's 1 minus lambda into bracket. That's 4 minus lambda, 1 minus lambda plus 2. Actually, that plus 2 is multiply.
Okay. I'm sorry. I have not
That
taken the
thing.
whole bracket.
If you plus 2, then getting the 6 actually.
I have not
That's
taken the
minus
whole
4
bracket.
lambda. That is 6 lambda and minus.
Okay. I have not taken the whole bracket. Right. So now I have taken the whole bracket. So now if I bring it inside, that plus 2 will become plus 2, and this plus 2 into lambda will be minus 2 lambda. Okay, so now it is fine. So that is going to be minus
11 lambda.
Yeah,
Minus 11 lambda.
minus 11 lambda. So if I bring everything to one side, it will be lambda cube minus 6 lambda square and plus 11 lambda minus 6 equal to 0. Okay, so the coefficient C is going to be minus 6 and coefficient D is going to be 11. So C plus D will be 5. Okay, so just we are adding the C and D in order to get, this is anyways wrong. This is anyways wrong. So we got the final answer to be 5. Okay, so from there it is simply calculation only. Okay, from there it is simply calculation only. I have done one calculation mistake here when I was multiplying this minus 2. Okay, I should have taken this whole bracket. Instead I have taken only only this inside the bracket. So that's a mistake, and finally I got the answer. Answer is 5. Okay, so others, the method anyways we have completed long before. Okay, so from there I was just doing the calculations. Okay, so I hope there won't be any doubts. So move to next question. I'll display the next question, try to solve that also. So any doubts? If there is any doubt, you just ask me you just raise your hands. Okay, there is an option to raise the hand. Yeah, try this question. Try this question. It is also a good question. Okay, it's a good question. They are asking us to find out, but we can directly do it. It's a small question only. They are asking us to find out what type of solution it is. The system of equation admits to what type of solution. 1 minute again. This question can be solved in 1 minute. It's a small question. B, no, B is wrong. B is wrong. See, it's from our basics. Okay, it's from our basics. Yeah, Hilal, it is right. See, it is very simple. If I take this is my A, if I multiply AX equal to B, A is what? 1 minus root 2, 3, minus 1 root 2 minus 3. Okay, and our value is x1 and x2, which is equal to 1, 3. Okay, just multiply it. Just multiply it. Because anyways, here I have 1 second. Right. So, there has to be Z. I have left with that Z. There is no Z term for B, right? Okay, that is a problem. Right, no problem. There is no Z term, in fact. Anyways, I will just multiply this. Okay, so first row, first column, the Z term has been not given for B. Okay, for B, the Z term itself not there. But anyways, we will first multiply the first row and the first column. If I do, and obviously this is not a determinate. This is not a determinate solution. Okay, we are not going to get a determinate solution. So one thing is for sure, we cannot get a unique solution. So either it has to be infinitely many solution or it has to be no solution. If I multiply this and this, what I'm getting x minus root 2y plus 3z, which is equal to 1. And if I multiply this and this, it is minus x plus root 2y minus 3z equal to 3. Compare these two. Compare these two equations. Or I will just multiply minus 1 here. What happens? X minus root 2y plus 3z, which is equal to minus 3. Okay, this is my first equation. This is my second equation. I have two equations only. I have two equations only, and I have three unknowns. So it is an underdeterminate system. Okay, it's not a determinate system. It's an underdeterminate system where the equation is less than that of unknown. So it is an underdeterminate system. And if you see the equations, compare this equation 1 and equation 2. X minus root 2y plus 3z, x minus root 2y plus 3z, which is equal to 1 here and which is equal to minus 3 here. So what type of equation it is? It's a planar equation, we know. It represents one plane, plane 1, and the second equation represents second plane. And it is very clear these two planes are parallel to each other. Okay, their slopes will be same. Okay, slope of this equation and slope of this will be same. So they are parallel to each other. Okay, so directly I can conclude it in that way itself. Since they are parallel, there is no way where they can intersect. Okay, there is no where they can intersect. Okay, no intersection. If there is no intersection, there is no solution for them. Okay, since I hope you could understand, their slopes are same. Its coefficient, the coefficient of y, the coefficient of z, and similarly its coefficient of x, coefficient of y, and coefficient of z all are same. So those two will be having same slopes. Since they are having same slope, both of the plane will be parallel. Since they are parallel, there is no intersection, there is no solution for it. I will get a solution when there was some intersection. Okay, if there is no intersection of the line or the plane, then there won't be any solution. So option C is correct. Yeah, good Hilal, good Kishore. Yeah, others also try to participate. Okay, that will be better. So was there any doubts here? Okay, see, just be open to ask doubts. If you have any doubts, just ask doubts. Okay, there is nothing wrong in that. You just ask doubt if you have any doubts. Yeah, move forward. Next question. Try this. Yeah, try this. Try this question. I'll just give you 1 minute. Okay, any answers? Yeah, I got one answer. You mean one, right? I guess one.
Yes, sir.
Yeah, one. Okay. Right. One is correct. One is correct. One is correct. It's a simple question. See, they are asked. They said that A is a 10 cross 10 matrix and A power 5 is a null matrix. See, A power 5 null matrix means A power 5 will be 0. What is this type of matrix called as? A power 5 becoming 0, or simply we can say that A power k equal to 0, where k is equal to 5. Okay, it is a nilpotent matrix, right? It's a nilpotent matrix, a matrix with a nilpotent index of 5. Okay, a matrix, a nilpotent matrix with a nilpotent index of 5. Now they are asking us to find out what is the determinant of 1 second, A power yeah, A plus 1. Okay, so A plus 1, sorry, and A plus I am deciding. So determinant of A plus I. Okay, see, determinant. One second, I guess there was some printing mistake here. Because A plus I is nothing, we can directly do it. Oh, just 1 second, I guess there is a printing mistake here. Okay, no problem. A plus I, that's what they're asking us to do. Okay, no issues. They're asking us to find out A plus I, right? Okay, determinant of A plus I. Okay. See, from the property we know, that is from the property, we don't know what is this matrix A. Matrix A is unknown. Okay, matrix A is unknown, but we know I is nothing but an identity matrix, which we eventually know. Okay, and I can write this as determinant of A plus determinant of I. That is fine, but the problem is I don't know determinant of A. Okay, A determinant is not known. Okay, so with this I won't able to solve it. The clue which has been given to us, the first thing is the clue which has been given to us is A power k equal to 0. This is A power phi is equal to 0. They are not saying anything about A. Okay, they didn't say A is a null matrix. A is not a null matrix. A power phi is a null matrix. Since A power phi is a null matrix, A is a nilpotent matrix. Okay, A power phi is a null matrix. A is a nilpotent matrix. You might think that I can write this determinant of A plus determinant of I, something like that, and you can make determinant of A to be 0 and determinant of I to be 1, which will be equal to 1, but this is wrong. Okay, the procedure is wrong. Of course the answer is correct. Okay, answer is 1, but this procedure is wrong because they have not given A is a null matrix. Okay, they said A power phi is the null matrix. Since A power phi is a null matrix, A power phi is a null matrix, A is a nilpotent matrix. Okay, so just that difference is important. Okay, anyways, the answer will be same, but getting the answer is not important right here. Getting what is the correct step, what is the correct way, that is important. Getting the answer, we can directly get it. We can say that 1 is the answer and then we can move forward, but that approach is wrong. Okay, right, no problem. We will see what is the approach. So even though if I write it as determinant of A plus determinant of I won't able to solve this further. I know determinant of I is 1, but determinant of A is unknown. Okay, so what I can do? Let me just think in that way. That is, think from that perspective. One way is directly applying the property determinant of A plus determinant of I is equal to determinant A plus I, but that doesn't work here. Okay, that is not working here. So we have one more property related to determinant. What is that property? Determinant is nothing but the product of eigenvalues, right? Product of eigenvalues. And if I able to find out the eigenvalues corresponding to this matrix, okay, if I able to find out eigenvalues corresponding to matrix A plus I, then if I find out the product of them, it will give me determinant A plus I. Okay, and for this we can use this clue. Okay, if the matrix is a nilpotent matrix, we know that A matrix is a nilpotent matrix, and if the matrix is nilpotent matrix, all its eigenvalue will be 0. Okay, all of the eigenvalue for a nilpotent matrix will be 0. This is one new property which I'm introducing here. Okay, for a nilpotent matrix, all the eigenvalues will be 0. So eigenvalue of A, you take any eigenvalue, all the eigenvalues will be 0. All eigenvalues of A will be 0. Okay, and now eigenvalue of A plus I can be written as eigenvalue of A plus eigenvalue of I, and we know eigenvalue of A is 0 and eigenvalue of I is always 1. So eigenvalue of A plus I is 1 always, which means let it be like it is a 10 cross 10 matrix, right? So I will be having 10 eigenvalues and all the 10 eigenvalues will be 1. Okay, all the 10 eigenvalues of A plus I is 1. So product of eigenvalue will be 1 into 1 into 1 into 1 until 10 times I need to do. That is going to be 1. See, answer is same. That is absolutely true. But the difference is we cannot say determinant of A as 0. That's what my concern is. Okay. Okay. Right. Anyways, when we come back to the property again here, we can use this eigenvalues and then we can bring the determinant of A plus I to be 1. Okay, let me move to the next question. See, you just for all, just note down this property, okay, in a separate notes. Yeah, moving to next question. Try this. Again, I will give you 1 minute time. Okay, 1 minute, 1 minute. Try it. We'll move to next question. Okay, so let me do it. In between, if you get the answer, it is fine. Option B. Option B is wrong, Kishore. Option B is wrong. Okay, let me do. They given that P and because it's already 45 minutes, so let me speed up a little bit because we have completed only 6 questions. So let me speed up a little bit. So right, so P square plus Q square has been given as 1. And the eigenvalues of the matrix PQ, Q1 minus P, that's what they're asking. Okay, right. See, we know one thing, we can write the characteristic equation directly as lambda square minus sum of the, what is that, sum of the roots, there's nothing but sum of the eigenvalues, plus determinant, which is nothing but product of the eigenvalues, right? So lambda square minus sum of the eigenvalues are nothing but trace. Some of the eigenvalues are nothing but trace, which means P minus P. Some of the eigenvalues are nothing but some of the diagonal elements, which is P minus P into lambda. Plus determinant is minus P square plus Q square. I am finding out determinant for this 2 cross 2 matrix, which is equal to 0. This anyways will become 0. So lambda square plus minus P square plus Q square equal to 0. Okay. So I can write, I can, one second, minus P square minus Q square. I'm very sorry. Minus P square minus Q square, right? Determinant. Yeah, correct, Kishore. Minus P square minus Q square. Yes. Minus P square minus Q square. So lambda square will be equal to P square plus Q square if I bring both the terms to that side. The lambda square will be 1 because they have given us P square plus Q square equal to 1. So lambda equal to plus or minus 1. So that is option C. Okay. Right. Okay, moving to next question. Again, you can take the notes later from the video. So I just want, like, what you guys try to do, see the question, try to solve. Okay. Yeah, now try to solve this. I will give you exactly 1 minute time. See, 1 minute time, sometimes it won't be sufficient, but I'm just giving you some time to try. Okay, so try to solve it. Even though if you couldn't solve it completely also, the trying is what I need. Okay, I don't need the answer. I don't need anything else. I just want you guys to try. Yes, any answer? It's an interesting question. It has like 2-3 layers in the question. There is 2-3 layers in the sense there are keywords. There are some good keywords in the question. So let me start doing it. If you get the answer in between, you can comment it. Okay. So a real 2x2 non-singular matrix. So non-singular is the first word which they given, which means the determinant cannot be equal to 0. The first keyword. Okay. Second, with a repeated eigenvalue. So what it says, the eigenvalue repeats. Okay, the eigenvalues are not going to be distinct. For example, if I take lambda equal to 1, 2, 3, okay, it's anyways 2x2 matrix. Okay, 1, 2, it's a distinct eigenvalue. Okay, distinct or different or unique. In any way I can use any of this keyword I can use if they say distinct eigenvalue, different eigenvalue, or unique eigenvalue. But here they said repeated, which means lambda 1 will be equal to lambda 2, which will be equal to some lambda, maybe 1 or maybe 2 or maybe something, some value which is going to be same. So that is what this repeated word indicates. Okay, so that is our second keyword in the question. Okay, moving forward, x is a real positive number. So real positive number, that is the third keyword. Okay, see, you might think that, sir, where this is going to be useful, why you are underlining all these things. It is going to be useful. Just wait, you will understand. All these three keywords are going to be useful to us. Okay, so let us start with the problem. They are asking us to find out value of x. So x is what they are asking us. Okay, I got one answer, it seems. 10 is correct. All 10 is correct. Okay, so they are asking us to find out x, and they have given us a clue related to eigenvalues, right? So let me try to find out eigenvalue. From the property, we know lambda square minus sum of the eigenvalue, which is nothing but trace, which is x plus 4, into lambda plus determinant, that is product of the eigenvalue, which is 4x minus of minus 9, which will become plus 9, which is equal to 0. Okay, so sum of the eigenvalue, product of the eigenvalue. Okay, right. Now, if I want to find out solution for this, okay, if I want to find out solution for this, we will use the basic equation minus b plus or minus root of b square minus 4ac by 2a, which is nothing but my b. What is my b here? First, I will highlight it. This is my b, right? That is, b is nothing but minus x plus 4. And my c is 4x plus 9. And my a is 1. So coefficient of the square term is my a, coefficient of the power 1 term is x, that is b, and the constant term is nothing but our c. So I have a, b, c, all three was there. Now, as I said, I will be using the keywords, right, which is given in the question. They said it is repeated eigenvalue. They said it is repeated eigenvalue. Let us consider like this. Let me just split it up. Minus b by 2a plus or minus root of b square minus 4ac by 2a. I'm just splitting it up. Okay. So when it will be repeated, I have to have same eigenvalue. Lambda has to be equal to lambda comma lambda. Okay, that means the lambda should be same. It should not be different. It will not be different if this term vanishes. If this term vanishes, it will not be different. What happens if that term is present? If this term is present, plus or minus, right? For example, let me take minus 3 plus or minus 2. Then I will be having minus 3 plus 2, comma minus 3 minus 2. So I will be having two eigenvalues. One will be minus 1, another one will be minus 5. So I will be having two eigenvalues which are different, okay, which are different. But I want repeated eigenvalues. If I want repeated eigenvalues, this total term has to become 0. So that is why I said keywords are important in the question which they given. Okay. So we are going to make this total term to be 0. Of course, 2a cannot be 0, okay, because it is 1. We already know a is 1, right? It cannot be 0. So the numerator, which is root of b square minus 4ac, has to be 0. And we know b is x plus 4, so it is x plus 4. I will apply square on both sides, okay? So minus 4 into a is 1, and what is my c? C is 4x plus 9, which is equal to 0. So x square plus 8x plus 16 minus, bring that 4 inside, so it becomes minus 16x, and then minus it is 36, which is equal to 0. Now solve this. So from here, I hope it is your task to do. Okay, because solution and all. Okay, that plus 8x and minus 16x will become this plus 8x and minus 16x. It will become minus 8x, and plus 16 minus 36 will become minus 20, which is equal to 0. So this is why this is my x. This I can solve. Okay, this I can solve and get the answer. Just give me the answer. What is my x value which I'm getting? Use the same formula, minus b plus r minus root of b square minus 4ac by 2a. Yes, everyone try. Those who are there in the live. Hilal has already answered. Others other than Hilal. Okay. 10 or 6. No. 10 or 6 is completely wrong, Kishore. Use this formula and get the answer. Or if you could split it directly, you split it. Okay, either use the formula or you directly split it. Okay. Yes. What happened? Okay, 10 is fine. That is only one root, but we have square. Okay, we have x square. So we will be getting 2 roots for this equation. 10 and minus 2. Yeah, that is correct. 10 and minus 2. That is correct. And now we have another keyword that the x has to be real and it has to be positive. Anyways, 10 and minus 2 both are real, but it has to be positive. So minus 2 cannot be our answer. Okay. So x is equal to 10 is the correct answer. So if this positive word is not there, okay, if this positive word is not there, then we have two answers for this question. 10 and minus 2 both are correct. Okay, since due to the presence of the word positive, minus 2 should not be included. Okay, so the correct answer is 10. So no doubts, right? Moving to next question. Try this one. So any answers? It's an 1 mark question only, a smaller question. Okay, let me solve this. It's a good question. It's a question from our question bank. Okay, so I want to. They said that f of x, g of x, and h of x, all three are polynomials of degree 3. Okay, and they given pi dash of x equal to f dash of x, g dash of x, h dash of x, and the second row is the second derivative, third row is the third derivative. Okay, they are asking is a polynomial of degree dash. Okay, this determinant, okay, determinant of this value is a polynomial of degree dash. Since they given f of x and g of x and h of x, all three is a polynomial of degree 3, we can clearly say f4 dash of x and g4 dash of x and h4 dash of x, that is 4 times differentiation. What will happen to all this term? See, it is power, it is degree is 3. Okay, its degree is 3. So if I differentiate it 4 times, it will become 0. Exactly, it will become 0, right? Fourth derivative of a third degree polynomial is 0. So let me differentiate this pi. Okay, let me differentiate this pi. So if you want to differentiate matrices, okay, that is a determinant, you have to do it row by row or column by column. Okay, so I will do one thing. I will first differentiate this first row. If I do, it becomes f double dash of x, g double dash of x, h double dash of x. Okay, and the second row and third row doesn't change. Okay, the second row and third row doesn't change. When you do this, what is that? When you do differentiation, okay, for a determinant, next you go for the second row. Okay, so when you differentiate the second row, first row and the third row will not change. First row and third row will not change, and the second row will become f triple dash of x and g triple dash of x and h triple dash of x, and fourth row will be f triple dash of x, g triple dash of x, and h triple dash of x. Okay, and third time you differentiate the third one. Okay, keep the other two constant. Okay, so that first two rows are going to be constant anyways, there won't be any problem. Right, and the third row, it becomes fourth power. Okay, that is fourth order. Okay, I need to differentiate it 4 times. Yeah, now check what's happening. First row and the second row are identical. Okay, so we know that determinant for like if any 2 row or any 2 columns are identical, determinant for that matrix will become 0. And here second row and third row are identical, so again determinant is 0. And here we know f fourth, that is the fourth derivative of f is 0, fourth derivative of g is 0, and fourth derivative of h is 0. So if in a row, if it contains only zeros, then this determinant is also going to be 0. So what is the conclusion? First derivative of pi of x, first derivative of pi of x is 0. So what I can say, first derivative of pi of x is 0. Yeah, try answer it, respond. What happened? What I can say if my first derivative is 0? If my first derivative becomes 0, what does it mean? It is a constant. See, for a constant, if phi of x is a constant, I don't know why you guys are thinking this much. If phi of x is a constant, then only phi dash of x will be 0, right? So this phi of x is a constant, so it is actually not a polynomial at all. Okay, so it is not a third degree, it's not a fourth degree, it's not a fifth degree, it's simply a constant. So none of this is the correct answer. Okay, is it fine? Any doubts? See, just we learned one new thing, like how to differentiate a determinant. Okay, that might be a new thing which we learned here. So clear?
Hello, sir.
Yes, Hilal.
Can you repeat that thing? Not clear.
Which one? Which one?
The derivation of the determinant, that phi dash x.
No. See, you know that differentiation of UV, right? What I will do in case of UV, I will differentiate one and I will keep other term constant, which is equal to U dash into V plus V dash into U.
Yes,
Same way, when I go for determinant, that is when I go for the matrices, first row you differentiate it, keep the other two constant. Okay, then you differentiate the second row, keep the first row and the third row constant. Then you keep first and
Okay,
second
okay,
row.
okay, sir.
Yeah, in the third row you need to differentiate. It's similar to UV method.
Yeah, yeah, yeah.
Yes, yes. Okay. Others, any doubts? Okay, right. Try this. Option A, B, C, and D. Yeah, try to solve this. Okay, so we'll go to the next question. Any answers? Again, this is also a question from our question bank. Yeah, any answers? Right. So if delta k, which has been given some matrix, and they said that the delta k is the determinant of that matrix, and then the value of k is equal to 1 to n, that is summation of k is equal to 1 to n, delta k depends on dash. Okay, they have given number of options. Okay, see, first we will take what is this k is equal to 1 to n delta kn. Okay, which will be equal to see, I will do one thing. I will take this entire term to be A and this entire term to be B, this entire term to be C. Okay, which means not exactly that entire term. Let me just once again, let me come for it. Okay, just a moment. See, here we are varying the k, right? So k is getting varied from 1 to n. Okay, k is getting varied from 1 to n. Alpha, beta, and gamma, that is the second row, doesn't contain any k. Okay, doesn't contain any k. So if I apply k is equal to 1 to n, the second row is not going to vary. It's going to be alpha, beta, and gamma only. And third row also doesn't contain any k. So it's going to be 3 power n minus 1. And it is 4 power n minus 1. And this is 5 power n minus 1. But the first row contains k, right? The first row contains k. So here A is nothing but summation of k is equal to 1 to n, 2 into 3k minus 3k to the power of minus 1. I'm sorry, k will be having power minus 1. Yeah. So this is my A. And B is nothing but summation of k is equal to 1 to n, 3 times of 4, 3 times of 4k minus 1. And C is nothing but summation of k is equal to 1 to n, 4 into 5k minus 1. So individually, I need to find out this series value. There is sum of the series value. And if I find out the sum of the series value, I will substitute here. Then you can find out the determinant, nothing. Okay, that's it. Okay, right. So I can easily do it. How I can do? First, let me expand this. First, if I put k is equal to 1, it is 2 into k is 1. So 1 minus 1, which is 0. Sorry, 1 minus 1, 0. So 3 power 0. 3 power 0 is anyways 1. Okay. Plus, if I put k is equal to 2, okay, 2 into 2 minus 1, which is 3. If I put k is equal to 3, 2 into 3 minus 1, which is going to be 2, etc. Right? So what type of series it is? What type of series it is? 2 plus 2 into 3 plus 2 into 3 square plus 2 into 3 cube, etc. What type of series? What type of series? Series. What type of series? I was expecting at least one answer. See, it is geometric series. I don't know what happened. It's a geometric series, right? Until 2 into 3 power n, it will be keep on going because from k is equal to 1 to n, we are doing it. So until 2 into 3 power n, it will be going. It is a geometric series with the a value, that is a comma ar square until ar power n. Here the first term is a and the common difference is r. Okay. So geometric series, yes, geometric series or geometric progression. So here r is 3. Okay, second term by first term or the third term by second term, r is 3 and a is 2. And we know geometric series is nothing but, that is the summation of the geometric series is nothing but a into r power n minus 1 by r minus 1. Okay, from like for a finite series. For a finite series, this is our formula. For infinite series, it is a by 1 minus r. Okay, that is for an infinite series, geometric progression. For a finite series, a into r power n minus 1 by r minus 1. So a is 2, r is 3, so 3 power n minus 1 by 3 minus 1. Okay, which is nothing but 2 again. So 2 will get cancelled. So it will become 3 power n minus 1. So our a is 3 power n minus 1. And now let me find out B and C also. Okay, so from like once we do one thing, like the other two will be very easy. Okay, so if I put k is equal to 1 minus 1 0, so it is 3 only. Plus if I put 2, so 3 into 4. If I put 3 into 4 square and etc. until 3 into 4 power n minus 1. Here also I'm sorry, 2 into 3 power n minus 1 because it is k minus 1, right? In place of k, if I replace n, it will be 3 power n minus 1. Okay, so this is my b. Again, this is a geometric series, so I can use the same formula. And if I use it, a is 3 here and r is 4 here. So 4 power n minus 1 by n minus by r minus 1, which is 4 minus 1, which is 3. I can cancel it. It becomes 4 power n minus 1. And what about this? Substitute 1. It is 4. 2. It is 4 into 5 power 1 plus 4 into 5 power 2, etc. until 4 into 5 power n minus 1. As usual, it is a geometric series. A is 4. So it is 5 power n minus 1 by 5 minus 1. Again, 5 minus 1 and 4 will get cancelled. It becomes 5 power n minus 1. So this is my C, this is my B. So C is 4 power n minus 1 and C is 5 power n minus 1. Now see, first row is 3 power n minus 1, 4 power n minus 1, 5 power n minus 1. Third row, 3 power n minus 1, 4 power n minus 1, 5 power n minus 1. So row 1 and row 2 are identical. So what will be my determinant value? Row 1 and row 3 are identical. So my determinant is, yes, my determinant is 0. So our answer, so they're asking this, that is the series depends on dash. That's what they're asking. So it depends on what? Out of the given data. It depends on nothing because answer is 0. Depends on nothing. So it is C, none of alpha, beta, and gamma. Okay. Yes. Option C is correct. Any doubts? Any doubts in the procedure? Any doubts in the problem? Okay. So we have 5 more in the matrices. I will do the balance 5 more question in the next session and then continue with the differential calculus. Okay.